10 real DevOps engineer interview questions from a Quest to Offer mock interview. Pause on each one, think how you'd answer. Then I'll show you how. Question 1. How does a Kubernetes pod go from pending to running? Pending means the pod is accepted but not yet scheduled, or its images aren't pulled. The scheduler picks a node by resources, taints, and affinity. Then the Kubernetes pulls the images and starts the containers, and it goes running. If it's stuck pending, it's almost always no schedulable node, not enough resources or a taint, or an unbound volume claim. Question 2. How do you design a CI/CD pipeline with zero downtime deploys? Build the artifact once and promote that same immutable image through every stage. Roll it out with rolling, blue, green, or canary, so the old version keeps serving until the new one is ready. Gate on health and readiness checks, and automate rollback on failure. And keep database migrations backward compatible. Expand, migrate, then contract. Question 3. Blue-green versus canary deployment. When do you use each? Blue-green runs 2 full environments and switches all traffic at once. Rollback is just switching back instantly. Canary sends a small percentage to the new version, watches the metrics, then ramps up. Blue-green is simple with fast rollback but costs double the infra. Canary limits the blast radius but needs good metrics. Use Canary for risky, large-scale changes. Blue-green for fast, clean cutovers. Question 4. What's the real difference between a container and a VM? A virtual machine virtualizes hardware with its own kernel, gigabytes, slow to boot. A container shares the host kernel, isolated by namespaces and cgroups, megabytes, and it boots in milliseconds. So containers win on density, speed, and portability, while VMs give stronger isolation, and a container image is layered and immutable, so the exact same image runs everywhere. Question 5. In Terraform, what is state and why does it matter? State maps your configuration to the real resources that actually exist. It's Terraform's source of truth. It diffs your desired config against state to build the plan. Store it remotely with locking, like S3 plus DynamoDB, so the whole team shares one state with no races. Never hand-edit it and protect it. It can contain secrets, so keep it encrypted. Quick pause. These questions come from Quest to Offer's AI mock interview, technical or FANG format. The AI asks questions for your exact role, you answer in writing, and you get a breakdown of your weak spots. Try it free at quest2offer.ai. Then back to the questions. Question 6. How do you manage secrets securely across Kubernetes namespaces? First, never bake secrets into images or commit them. And remember, Kubernetes secrets are only base 64, not encrypted. Turn on etcd encryption at rest and use an external manager like Vault or a Cloud KMS. Inject them at runtime through a CSI driver or a mounted volume and scope access with RBAC per namespace. Then rotate on a schedule and audit who reads them. Question 7. What are the 3 pillars of observability? Logs, metrics, and traces. Logs are discrete events, metrics are aggregated time series, and traces follow one request across services. Metrics tell you something's wrong, traces show you where, and logs show you why. Correlate them with trace IDs in your logs for fast root cause. And remember, observability isn't just monitoring, it's being able to ask new questions about failures you didn't predict. Question 8. What's an error budget and how does it change how you ship? An SLI is a measured signal like the percent of requests under 200 milliseconds. The SLO is your target, say 99.9%. The error budget is 100% minus the SLO, the failure you're allowed to spend. Budget left, you ship features fast. Budget burned, you freeze and fix reliability. The SLA is the contractual promise with penalties, usually looser than the SLO. Question 9. Service mesh versus a plain sidecar. When is a mesh worth it? A sidecar is a proxy next to one service. A service mesh is all those sidecars plus a control plane. The mesh gives you mutual TLS, retries, traffic shifting, and observability with no application code changes. The cost is extra latency and real operational complexity with Istio or Linkerd. It's worth it at scale with many services. For just a handful, a library is simpler. Question 10. A production service spikes in latency. What are your first moves? Start at the dashboards. Which service and endpoint when it started and what the last deploy was. Scan the 4 golden signals: latency, traffic, errors, saturation. And check dependencies like the database, cache, and upstreams. If a recent change lines up, roll it back first, mitigate before you root cause, and communicate status while you capture a timeline for the post-mortem. That's all 10. How many did you get? Tell me in the comments, then like, subscribe, and try a real mock interview at quest2offer.ai. Good luck on your next one.